Your woodworking vise is failing because of one invisible 3-cent mistake. 1. You are leaving the screw threads dry and exposed to dust. Metal friction heats the steel, causing microfractures in the mounting bolts. Apply white lithium grease to the threaded lead screw every 6 months to prevent catastrophic metal fatigue. When the threads run dry, the friction generates localized heat that microscopically fuses the steel surfaces, causing them to gall and eventually shear under load. This chemical breakdown turns a smooth turning motion into a grinding process that eats away at the structural integrity of your vise. To fix this, thoroughly clean the old, gritty residue from the grooves using a stiff nylon brush and a solvent like mineral spirits. Once the metal is clean and dry, apply a thin, consistent bead of high-pressure white lithium grease across the entire length of the screw. This simple application creates a protective barrier that reduces friction by 90%. Tightening the handle with your entire body weight rather than just your wrist snaps the cast iron housing or bends the lead screw permanently. Most vises are manufactured with a specific tensile strength designed for hand torque only. When you put your back into it, you apply over 200 pounds of force, which exceeds the yield point of the metal casting. The resulting stress fractures are often invisible at first but propagate quickly through the molecular structure of the iron. Instead, use only the weight of your hand to clamp workpieces firmly. If you feel the need to lean into the handle to keep the board from shifting, your vise is likely too small for the job, or your clamping technique is fundamentally flawed. Clamping uneven boards on only one side of the jaw creates lopsided pressure that twists the steel guide bars completely out of alignment. Because the lead screw is centered, applying force to the far left or right of the jaw creates a massive fulcrum effect. This leverage forces the guide bars to bind against the vise body, creating a permanent 0.05-inch deviation that prevents the jaws from ever meeting flush again. To stop this, always place a scrap block of equal thickness on the opposite side to balance the load perfectly. This ensures that the clamping force is distributed evenly across the entire face of the jaws, keeping the guide bars parallel and preventing the internal mechanism from binding or warping under pressure. Stop over-tightening the handle to prevent lead screw stripping. The internal threads inside the vise nut are softer than the screw itself, meaning the nut will fail long before the screw snaps. Once you strip just 3 of these internal threads, the vise will lose its ability to maintain a consistent grip, causing your workpiece to slip during critical operations like chiseling or planing. That tiny 3-cent tube of grease is the only thing keeping your vise from snapping in half, but your technique is the final variable. When you reach the point of initial resistance, give the handle only a quarter turn more. That is the exact threshold required for a secure hold without compromising the structural longevity of the vise housing. Fine sawdust particles inevitably migrate into the threaded screw assembly, creating a grinding paste that accelerates wear on the internal metal grooves. When you operate the handle, these tiny jagged wood fibers act like sandpaper, wearing down the brass or steel threads until they lose their precise engagement. Over time, this friction prevents the vise from gliding smoothly, eventually stripping the threads entirely. To stop this, grab a stiff nylon brush every 30 days and thoroughly clear out the debris from the main screw shaft. Once the threads are clear, apply a thin, consistent layer of white lithium grease to the entire length of the screw. This simple maintenance routine keeps the mechanical movement fluid and prevents the metallic galling that ruins expensive vise components. Clamping a workpiece only on one side of the vise face forces the sliding jaw to pivot against the guide rods, which creates significant mechanical stress on the rear housing. This uneven pressure causes the metal to bind and eventually twist or crack under the lopsided torque. A vise is designed to distribute force evenly across its full width, usually measuring about 9 inches wide on standard models. If you frequently clamp smaller items off-center, the internal guide rails will permanently deform, leaving your jaws permanently misaligned. Always use a scrap block of equal thickness placed on the opposite side of the jaw to balance the pressure. This ensures the clamping force remains perfectly parallel and prevents the catastrophic structural failure that occurs when one side takes all the load. Using the top of your vise as an anvil for heavy hammering transmits massive kinetic energy directly into the cast iron or steel frame. Most woodworking vises are engineered to handle linear compression from clamping, not the high-impact shock of a 2-pound steel mallet striking the surface. This repeated jarring impact creates microscopic fractures throughout the cast material, which eventually lead to a sudden, clean break across the mounting flange. If you need to shape metal or drive heavy fasteners, move that work to a dedicated steel anvil or a solid piece of hardwood mounted directly over a leg. Saving your vise for its intended purpose preserves the structural integrity of the jaw mechanism and keeps your tool from snapping in half during a project. Mounting bolts gradually work themselves loose because of the constant vibration and cyclical torque applied during daily operation. Even a tiny, 1 mm gap between the vise base and your workbench causes the entire unit to shift, which puts immense leverage on the mounting hardware. As the vise wobbles, that motion is transferred into the handle and screw assembly, causing the internal components to misalign and bind. You should perform a hardware inspection at least twice a year, specifically checking the 4 primary lag bolts or carriage bolts that secure the vise to the underside of your workbench. Using a socket wrench, ensure every nut is torqued down firmly against the bench frame to eliminate all play, which maintains the stability required for precision woodworking tasks. When your vise sits idle with the jaw extended, you create a massive lever arm that puts unnecessary stress on the screw threads. With the jaw pushed out 4 inches, any accidental bump to that overhang acts like a pry bar, putting hundreds of pounds of pressure on the nut. Over time, this constant leverage forces the screw to bind or even strip the internal threads, leading to a permanent wobble that no amount of grease can fix. Instead, always spin the handle until the front jaw sits flush against the housing whenever the vise is not actively holding a piece of lumber. This shortens the internal travel path to 0, ensuring the screw remains fully supported by the casting and preventing any accidental damage during your workshop workflow. Using a woodworking vise to bend a piece of a 1/4 inch steel or hold oversized stock for heavy-duty metalwork is a recipe for disaster. These tools are cast from gray iron, which is incredibly strong under compression but snaps like glass when subjected to the high-tensile shock loads common with metalworking. When you apply force to metal, the localized pressure exceeds the vise's structural design limits, causing microscopic fractures in the iron casting. Eventually, these fractures propagate, leading to a catastrophic failure of the entire jaw assembly. Switch to a dedicated machinist's vise for any metal projects or heavy bending tasks. These tools are forged from ductile iron or steel, specifically engineered to handle the intense impact forces that would destroy your woodworking setup in seconds. Guide rods are the precision alignment system for your vise, and they rely on a sliding tolerance of less than 0.005 inches to function smoothly. If you spill epoxy resin or allow sticky wood finishes like polyurethane to build up on these rods, that tolerance vanishes. As you tighten the vise, the friction from the dried gunk forces the rods to grind against the bushings, wearing down the metal surfaces and causing the handle to feel gritty or stuck. Instead of using harsh solvents, wipe the rods down with a dry rag every 30 days. If the movement feels sluggish, apply a tiny drop of dry PTFE lubricant. This keeps the mechanism gliding perfectly without attracting the sawdust and debris that lead to premature mechanical failure. Mounting a heavy-duty vise onto a workbench top that is less than 1.5 inches thick creates a dangerous flex point. When you apply torque to the handle, that thin wood acts like a spring, causing the entire vise to tilt or pull away from the table surface. This misalignment puts uneven pressure on the guide rods and the lead screw, forcing them to twist rather than push in a straight line. This constant torque causes the mounting bolts to wallow out the holes in your bench, eventually leading to the vise ripping right out of the wood. Use a solid wood slab at least 2 inches thick or bolt the vise directly into a steel plate reinforcement to ensure the base remains perfectly rigid under pressure. What is the oldest tool currently sitting on your workbench right now?